section is the fifth one called angle relationships. Okay. This is probably the section that there would be the most questions on the quiz about, if that makes sense. Okay. So this is probably the most important section of the ones we will do in this chapter. Now, also just a reminder on, let's see, I see you guys again on Wednesday. On Wednesday, you will have, we will finish the chapter and do the review. You'll get a review guide for the test. That means on Friday of next week, you'll have a test over this chapter. Okay. So Wednesday review, Friday test next week for this chapter. Okay. This is 1-5, right? With angle, first I showed you guys the magic gopher. Did we ever go over the answer to that? Yeah. So, if we get time, I'll come back to it today. I had that in here last year. Okay. These are the big three things you need to know from this chapter. Now, I wouldn't write down every single thing here, maybe abbreviate it, but these are the three angle pairs that you need to know from this chapter. The first one is called adjacent angles. Like if you live adjacent to someone, what's that mean? Next to, right? So adjacent angles are angles, the formal definition are two angles that are in the same plane, have a common vertex and a common side, but no common anterior points. What that's saying, okay, in this case, ABC, this angle right here, is adjacent to angle CBD, this angle here. They share a vertex and they share a common side. They're next to each other. They're adjacent. Okay? So we're going to talk about adjacent angles. Also in this figure, ABC is adjacent to CBD. Those are adjacent angles. They share a side. They share a vertex. Okay? They don't share any interior points because, for example, these are non-examples. So here, ABC is this angle right here. That is not adjacent to ABD, that whole angle, okay? Because that red angle is just a smaller part of that blue angle, right? And they share an interior point. Adjacent angles just share a vertex and share a side, okay? So that is not an example. Same thing with this one here. ABC, this angle right here, is not adjacent to BCD, because they don't share a vertex. They do share part of a side, okay, but they don't share a vertex, so they're not adjacent. That one is not adjacent. Adjacent, next to, okay, angles share a vertex, share a side. Vertical angles, okay, vertical angles are formed by two intersecting lines, and they're on opposite sides of those intersecting lines. For example, here I have two intersecting lines, right? AEB, so if I look at that, AEB, that is this angle right here, okay, is vertical angle with CED, this angle right here. They're opposites of each other, two intersecting lines. Basically, they make an X and it's opposite sides of the X. Okay, that's what we call a vertical angle. A very important theorem about vertical angles, which we'll get to in just a second, is that all vertical angles are congruent. They're exactly the same measure always, okay, which will help us a lot in some problems we do. Those are vertical angles. We also have another pair of vertical angles here, that AED, that one right there, is vertical with BEC, because they're on opposite sides of that intersecting line. Okay, those we call vertical angles. Two lines that intersect each other, okay, opposite sides of that are vertical angles. The non-example here, AED, this angle is not vertical with BEC. Anybody tell me why that is? Yeah, they're not formed by two intersecting lines, right? I have one line here, and then this one, okay? I have two line segments this way, or two line segments, okay? They have to be two intersecting lines that cross each other, okay? So in this case, these points are not collinear, so these are not vertical. Vertical, just think of an X, two intersecting lines, opposite angles that they make there are vertical. And the last one is called a linear pair. Linear means straight line, pair means two. Okay? So linear pair is a pair of adjacent angles, okay, where their non-common side is a straight line, or in this case we also call that opposite rays. Remember that last time? Opposite rays are a straight line. So here, DEB, that angle right there, and BEC form a linear pair because they're adjacent. They share a vertex, they share a side, but the side they don't have in common, this one, is a straight line. That makes them a linear pair. So a linear pair is a special type of adjacent angles. Okay? They're adjacent, but the side that they don't have in common is a straight line. That's the difference between it and adjacent angles. They're always adjacent, okay? But even more specifically, we have a linear pair. In this case, this non-example, DEB and BEC, those are not, because their non-common side is not a straight line. See, that's not a straight line. So that's why that is not a linear pair. Linear pair, their non-common side's a straight line, and they're adjacent. One very important theorem about a linear pair, which we'll talk about in just a second too. Linear pairs of angles always add to give you 180 degrees. If you add this angle plus this angle, or a linear pair, they always add to 180 degrees. So like if this angle was 80 degrees, this one would be 100. Okay? A linear pair, they always, that looks like a 9, 80 degrees. Yes, question.
Can there be one that has two? Like, can there be one that's vertical and adjacent?
Can there be both vertical and adjacent? Well, vertical angles are opposite sides of intersecting lines, so those are two different things, right? They can't be both of those things. But they could be adjacent and form a linear pair. Okay. We'll go over some examples of that in a second. Linear pairs add up to 180. Vertical are always the same. Okay. So let's look at some examples of identifying these. I want two angles here that form a linear pair, meaning they're adjacent and their non-common side is a straight line. There's several of them here. Anybody want to take a shot at one pair of them? Yeah. What?
YZV
YZV is a linear pair with what other angle?
with VZX.
Exactly. VZX. So I'll write it out here. Angle YZV and angle VZX form a linear pair because they're adjacent, they share a side, and their non-common side's a straight line. Okay? And we also know a linear pair add up to 180 degrees. Well, that's true. 115 plus 65 is 180 degrees. Okay? Those form a linear pair. And remember, did a nice job that the middle point is always the vertex. It doesn't matter if we said YZV or VZY, as long as Z, the middle point's the vertex. Okay? So that's one pair. Anybody got another pair? Yeah, Eric, what do you got?
VZX, XZ.
Exactly. VZX and XZY. Those form a linear pair because they're adjacent. Okay? And, or sorry, VZW. Yeah, I said that wrong. I'll write it out here. XZW and angle VZX. Those form a linear pair. Their non-common side's a straight line. They share one ray of an angle. They add up to 180 degrees. They're a linear pair. Okay? And there's a couple more. You know, we could say something like, this angle and this angle form a linear pair, right? This whole angle here and this 65-degree angle here form a linear pair. Their non-common side's a straight line. They share a side. Yeah. So could I have said, instead of breaking that up, you're saying, say, this one, and this one? Those add up to 180 degrees, but they're not a linear pair because linear pair just has two. Right, good question. Linear pair, we're just talking about two angles. Those three angles themselves add up to 180 degrees because they're part of a straight line. Okay? But linear pair, we're just talking about two. So there's a couple different ones there. Let's talk briefly, why is a straight line 180 degrees? Because we know an angle like this, 90 degrees, right? So then if I took this piece and flattened it out, so let's say I'll do this. There's my 90-degree angle, and let's say I dashed this one, like I cut it out, and then I moved it down there. That makes sense? Straight line, two 90-degree angles. It's also half of a circle, which how many degrees are in a circle? 360, right? So a straight line, anything on a straight line adds up to 180 degrees. So that's why that is. Very good. Okay. Let's look at one more here before we take off for lunch. Name two acute vertical angles. Okay, I want vertical angles, opposite angles of two intersecting lines that are acute. Acute means less than 90. What's a pair of those? I think there's just one here. Yeah.
VZY
Yep.
and XZW.
Excellent. VZY and XZW. Those are vertical. because two straight lines, they're opposites of two intersecting lines. They're acute because they're both less than 90. Okay, very good. So that's acute vertical angles. All right. Identifying angle relationships. In this case, let's pretend like there are no choices, so we don't have to look through. Okay. I want two adjacent angles whose sum, so added together, is less than 90. You guys can't see that because it's frozen. Let me fix that. Okay. Who could name? There's a couple sets here. Adjacent angles less than 90. Sum. Yeah, Carson.
FAE and FAE.
Right. FAE and angle fan. FAN here. Okay, those are adjacent. They share a vertex. They share a side. Their sum is less than 90. It is 85. Okay, very good. Name two acute vertical angles. Let's again pretend like that's not there. Okay. Acute vertical. Right, I heard a few. BAC. That's vertical with which one? FAE or EAF, right? Opposites of two intersecting lines. Okay, we could have also said CAD and FAN also. Those are acute vertical angles, less than 90, opposites of two intersecting lines. Okay, we're going to skip this lab. We may come back to it in class. Last couple things I want to talk about. We just mentioned this. All vertical angles are always congruent. Okay, so like here, there's one tick mark in each vertical angle here. Those angles are always congruent. Tick mark here, always two tick marks in each. Vertical angles are always congruent. So in this figure, okay, it says lines, there should be a line piece over this. Lines JK and GH intersect at point I. Find the value of X. Find what X is equal to, which will then give you JIH. Well, these are vertical angles, opposites of two intersecting lines. So if this angle is 16x minus 20, it's got to be the same as 13x plus 7. They're equal, right? Because they're vertical angles. So if I just write 16x minus 20 is equal to 13x plus 7, I can solve that equation for x. The reason I know that is because they're vertical angles and they're equal. You know, so you move the 13x to the other side of the equal sign, move the 20 over. You'd get something like 3x is 27. Divide both sides by 3, and x would be 9, right? So I did kind of multiple steps at once there. Yeah, that would go away, that would go away. All right, so x is 9. The other part of the problem says, what is JIH? So JIH, now that I have x is 9, right, I would plug that in there and take 13 times 9, which is 27. 117 plus 7 is 124, because I just plugged that x back into there. Okay. So JIH is 124, which means also GIK should also be 124. Okay. I know that because their vertical angles are equal. I could check my answer by plugging an x up there and making sure they get the same thing. Yes. I multiplied 9 by 13 here just because since x is 9, to find out what this angle is equal to, I substituted back in here and I did this multiplication and then added. Yep. The last two things we need to know about are complementary angles and supplementary angles. Okay? Complementary means two angles add together to be 90 degrees. Supplementary means they add together to be 180. Okay? The way I remember to tell the difference is C comes before S in the alphabet, right? And 90 comes before 180 when you're counting. So complementary is 90, supplementary is 180. Okay? Complementary add up to 90, supplementary add up to 180. So now instead of saying two angles add up to 180 degrees, we're going to say two angles are supplementary. Okay? And instead of saying two angles add up to 90 degrees, they are complementary. Complementary and supplementary, 90 and 180. Okay. C comes before S, 90 comes before 180. That's how we can tell the difference. So for example, okay, if I want to find the measure of two supplementary angles, so together they're 180, one angle is 6 less than 5 times the other. Okay. Let's call these angles X and Y. So it just gives it to me in words here. I want to find what these two angles are if one of them is 6 less than 5 times the other. Okay, I think there's 2 homework problems on this type of question. Okay, So let's call them x and y. I know since they're supplementary, x plus y has to be equal to what? Since they're supplementary. Yeah, 180. I'm just calling them angle x and y. You could call them something else. I know together they have to add up to 180. So that gives me one equation. But I can't solve this because there's two variables and only one equation. I need another equation. The other equation is going to come from here. One angle is 6 less than 5 times the other. So let's say my one angle is x. And it says x is, so I should write x equals 6 less than 5 times the other. So it's either going to be this or it's going to be this. Right? Which of these is 6 less than 5 times the other? Top or bottom? This one, right? This is 6 less than 5 times the other. So it's going to be equal to this. Now that I have two equations, I can solve for one of the variables. You either learned elimination or substitution. Okay, but remember this one is probably easier doing substitution. I can replace, since x is equal to 5y minus 6, I can replace this x. What would I replace it with? I would replace it with this, right? Because that's what x is equal to, 5y minus 6. I'll take this and plug it in right there. So I get 5y minus 6 plus y equals 180. Now I have a variable that's in, or now I have an equation that's in one variable that I can solve. Combine my like terms, 5y plus 1y, 6y. Add 6 to both sides. 6y is 186, and when you divide both sides by 6, you get something like 31. So one of those angles is 31 degrees. How are you going to figure out what the other one is? Yeah, they're supplementary. So if one of them is 31 degrees, I'm just going to take 180. You could also plug it back in here and solve this equation, which is exactly what you'd be doing. Okay. Since they're supplementary, I know if I take 180 minus 31, I get the other angle. So the two angles in this case are 149 degrees and 31 degrees.
So we can put 31 on the y side here?
Yes, you could put 31 back here, so then you'd subtract 31 from both sides, which is what we did here, and get x. I called them x and y. It doesn't matter what you call them because all it wanted was the two angles. So when you get a problem like this, just remember, if it's supplementary, you have angle 1 plus angle 2 is going to be 180, and then the other equation is going to be whatever it tells you here. Okay? And then most of the time, substitution is probably the easiest way to solve these. Occasionally, elimination might be, but most of the time, you're probably just going to solve it by substitution, by substituting in what x is here. Okay? Questions on that? Let's look at one more of those. So find the measure of two complementary angles. I'm going to go ahead and just erase these. We don't need them. Okay. Two complementary angles if one angle is 6 degrees less than 5 times the other. So again, let's call them x and y. Complementary means they add up to how many? 90. So I know x plus y has to be 90 because they're complementary. Now I need my other equation. One angle, let's call that angle x, is, there's not an is there, but I can kind of assume there is. One angle is 6 degrees less than 5 times the other. That's 6 degrees less than 5 times the other. Right? Then I would just substitute and solve. It's very similar to the last one, except this time they're complementary. Okay? So I could replace this x with 5y minus 6. So I would get something like 5y minus 6. Then I have plus y equals 90. Like terms, 6y minus 6 is 90. 6y is 96. So y is 16. When you divide both sides by 6 there. So one of those angles, is that right? Yeah. One of those angles is 16 degrees. Okay. What would the other angle be then if they're complementary? 74, right? One angle is 16, one is 74. Right. So that one's 16, the other one's 74. Questions on those? Those are kind of probably the trickiest problems in this section. Okay.
gonna be a couple of teachers on this one?
Yes, I think there's two. Yep. And then we have perpendicular lines. Okay, I want you to recognize you don't need to write all this down because all this is saying is what the symbol for perpendicular is. If two lines are perpendicular, and I'll write it bigger here, if I say line XZ is perpendicular to line WY, this is the symbol for perpendicular. It's like an upside down T. Perpendicular means the two lines intersect and they make 4 right angles. And the symbol for a right angle is this pink little square in the corner. Okay? Is this pink little square. This is how you know it's a right angle. This means perpendicular. Perpendicular means it makes the two lines make 4 90-degree angles. And the reason I know it makes 4 90-degree angles, because remember this is a straight line here, and on a straight line it's 180 degrees. So if this half of the straight line is 90 degrees, how much is this half? 90 degrees. Same thing if I look at it this way. I know this one's 90 degrees, so this one has to be 90 degrees. And then finally, if I look at it this way, I know this one's 90 degrees, so this one has to be 90 degrees. Okay? So that's how I know perpendicular makes 4. If they intersect, it makes 4 right angles. The word perpendicular means intersects to make 4 right angles. The symbol is this kind of upside down T. So when you see that, that's what that stands for. Go back.
So it's 4 right angles. I thought you wanted to start down.
No, sorry, you don't have to write all this in because this is just telling you what they do. No, it's too much extra stuff for this to say. If you know this symbol and they intersect to make 4 right angles, that's what you need to know. Okay? You know that symbol, they intersect to make 4 right angles, that's what you need to know. Yeah, I had a question. Somebody has a question.
Weird T thing.
Yeah, the upside down T looking. Okay. So, if in this figure I said line KO, so this line is perpendicular to HM. HM is this line. That means they're going to make 4 right angles, right? So I'm going to put those little square in the corner. So I put those in the corner. Find out what X is. Well, I have this little piece of this angle and I have this little piece of this angle. And together, how many degrees are those angles? They're 90 because they make up this right angle, right? Together, these two pieces make up this whole angle. So if I take 3x plus 6, this angle, and I add it to 9x, that's going to equal 90 degrees. And then I can solve this equation for x. Combine my x-like terms, I get 12x. Let's say I subtract that 6 over the other side, I get 84. And when you divide both sides by 12, you get something like 7. So this problem just says find x, there it is. If you had to find the angle measure, you would just go plug x back in, right? I'd plug it in here, I'd get this angle 63. I'd plug it in here and I'd get this angle's 34. Right? No, 63, no, sorry, not 34, 27. Okay? 27 and 63. So just know what this symbol means. It means the lines intersect, they make right angles. So in this one, very similar problem. We won't go through this. But I know if these are perpendicular, these two angles together add up to make up this 90-degree angle. So I know 5x plus 4x has to be 90. That's 9x equals 90. Divide both sides by 9. X would be 10. Okay? Well, that was just like the one we did before. The last thing, determine whether these statements are true. So can you say just by looking at this figure that XAY is 90 degrees? No. Why?
It doesn't have a little square.
Right, it doesn't have that little square in it. This could be like 89.999 degrees. I don't know it's 90 in a figure unless this is there. If that symbol is not there, you can assume it's not 90 degrees. It could be, okay, but you can't for sure say that it is 90. Determine whether this statement is true, that angle TAU, this angle, is complementary to angle UAY, which is this one. Are those complementary? No, I can't even be sure they're complementary anyway, but they definitely don't look complementary, right? But complementary, I'd have to see that there's a right angle somewhere, okay, for them to be complementary. Okay, there's like 2 or 3 of those also. And they have the little square in it, right, exactly. Yeah, so that's the end of the angle relationship section.